Section 2.3, number 50. We are given this complex number, minus 3 plus the square root of 2i, and we're told to find the complex conjugate. Now, our rule for complex conjugates, if we have a plus bi, the complex conjugate flips the sign of just the imaginary part. So we're going to get a minus bi. Okay? And if it's negative, it's positive, right? If we had a minus bi, the complex conjugate says it's a plus bi. We just flip the sign of the imaginary piece. The real part stays the same. So for this problem, the minus 3 is the real, so that stays just as it is. Plus 2 square root of 2i becomes a minus square root of 2i. Okay? Now, it also says to double check to see that these are complex conjugates by multiplying together. If they are complex conjugates, when we multiply these two numbers together, we should just end up with a real number. The complex bits go away entirely. Okay? So we multiply these things in just the same way that we do multiplying binomials, which we just did in the last example. Minus 3 plus square root of 2i times minus 3 minus square root of 2i. All right, now let's FOIL these out. We're going to get a minus 3 times a minus 3. Minus times a minus is a plus. 3 times 3 is 9. The outside, minus 3 times a minus square root of 2i. Minus times a minus is a plus. 3 times the square root of 2. I'm just going to write that as 3 times the square root of 2. And the I follows along. It is not a T, it is an I. Right? Plus square root of 2i times a minus 3. Plus and a minus is a minus. 3 times the square root of 2. I'm going to write that as 3 times the square root of 2. And the I, well, there's only the one of them, so it follows along. Square root of 2i times minus square root of 2i. Positive times a negative is a negative. Square root of 2 times the square root of 2 is 2. I times I is negative 1. Okay? Now, if the imaginary parts go away, leaving us with just real parts, we've constructed their proper complex conjugate. We have a plus 3 times the square root of 2i and a minus 3 times the square root of 2i. When we add and subtract the same thing, those pieces cancel out. Can this be simplified anymore? We have a 9 here, minus and a minus is a plus, plus 2, that's 11, and it is purely a real number. Therefore, we constructed the proper complex conjugate.